Welcome everybody, you're watching Mr. Fugu Data Science. Feel free to hit me up here on my socials as usual. Today's a little different. It's a little tip of the day basically. Time series data. What are some things that you should consider when you're dealing with date-time formatting? Specifically, time zone data. This is not necessarily a video of you coding out different examples. This is a video motivating someone who's getting into this and things to consider when you look at these type of data. This is different. This is tips to help you out in your career over the long term and to use abstract thinking. For instance, today we're gonna just show this simple example. This is from the USGS website, US Geological Survey people. These are some data that they have for earthquakes. For instance, they log all their data in this type of 13-digit formatting. It's not difficult to parse, but it's particularly interesting when you look at your observations. This is the motivation. For instance, if you're starting with some time series data, what kind of tips can you have for the future? If you're looking at this and you understand these data are dealing with worldwide observations, when we click on the website, for instance, to look at this, when you're looking at whatever your data source is, for instance, these are earthquakes, you have some instance for each one of these earthquakes, and it has this UTC formatting here and some observation time. Here are the important messages for you to think about now. When you're looking at observations for time series data, is this an observation based on when this incident occurred, or is the time that you're looking at this based on your local time? Let me explain. These data, depending if you're on a VPN, some local device, or whatever, could be actually implicit towards your device. Your observation time could be based on where you are geographically located based on a VPN or whatever it may be for how you're connecting to these data. That's very important because what you're looking at may not be the actual event time. I had to go and look at what these events were for some of these different ones to make sure that it actually coincides with an actual event, because the next thing that you need to consider is standardizing the times for your data. If you're collaborating with people who are in different parts of the world, you need to find a way to standardize it. Using something like this, a UTC formatting, can help you, because then people could say, okay, this is offset by X amount of hours from the standard time. This is the actual perceived time when an incident occurred, or this is a standardized time based on either your local device or a time that you format it to, which can be used by other collaborators around the world, such as changing this. You can convert this 13-digit code for your data really easy, but it's agnostic of any time zone. This would be considered an Epoch Time or 𝗍𝗗𝗄 time. That's something that you could look for if you're trying to Google this to figure out how to parse this later if you forget. You have 10-digit, which goes down to the second, 13-digit, which we have is in the millisecond, and then 16-digit, which I think is a microsecond. And you can just plug it into the date time module in Python and do a dot from timestamp. And since we have a 13-digit, we got to divide it by 1,000 to get our formatting, and we got to make sure that we have this as well. And this particular instance is from one of these occurrences for our data set, I should say. But if you notice, it doesn't have any relevant time zone information. It just has an actual occurrence time on a specific date. And I verified that these were actual times from news articles and not just a local device time, because it depends where you're pulling these data on a API or where this stuff is coming from and how it's logged. Let's click on this and explain something. Each data set is different. For instance, what piqued my curiosity was seeing this. The USGS utilizes this, and let me zoom in further so we can look at it. This specific data set utilizes the UTC, and they express that their data are recorded globally from various time zones using a single standard time reference, which can be best for your record keeping and exchanging of data. Since they are dealing with different data sources from people observing these earthquakes around the world in various time zones, it's good practice to standardize your data for one single reference point, basically. That's what they're trying to tell tell you is you grab these data from us, that's fine, but try to standardize it if you're doing collaboration work with people. Another interesting thing that you need to take from this, the individual event pages with details about each earthquake use UTC for the reference time. Sometimes this means the UTC date of the earthquake is the next day from the date of where you are. This is important. So you may format your data, it may end up turning your data into the next day when the observed day was prior, depending on geographically where you are in the world. This is something you need to take into consideration, please. It's very important. Let's click on this real quick for the Python documentation and mention two things that are extremely important when you're doing any kind of parsing for your day-to-day work in the future. Something called aware and naive objects for date time. To break this down simply, naive means that it's basically agnostic or it doesn't take into consideration any time zone information, whereas aware does. But what would this exactly look like? So here's your naive. You could pause the video and look at that, but it just goes over what I say. The UTC, Coordinated Universal Time, but you got to look at this local time or time from some time zone purely up to the program. If you're dealing with time.now or UTC now, try to avoid those. You could hit some pitfalls when dealing with your time. One option, which is an older version that you'll see often when people say, oh, convert it to time zone, import PYTZ, PyTZ. That's something you can use in an option. I decide to use the data frame option of to date time and do my conversions. That can work as well. If you're wondering about what the UTC is really doing, it's working off basically the measurements from the atomic clocks around the world, basing it off of multiple readings of different atomic clocks. It does not change according to daylight savings time. This is one consideration that you need to pay attention to also. Daylight savings time can really mess up your conversions for any of your date time information. Also, certain time zones from around the world can be problematic too if it's not a standard time zone. UTC is not considered a time zone. It's just starting at like UTC 00:00, and then anything basically west of that is going to be starting to go negative, and then east of that start going positive. And your country formatting, geographically this could be something you need to consider. The United States versus UK or other countries, for example, changing a month or a day in their positioning for your date time is something you need to consider as well. You could avoid having a time zone if it's all within some geographical location where you're referencing. You wouldn't have to necessarily say a time zone. If you are looking at these data and you're outside of that time zone, maybe you want to standardize it to where you live. That's up to you. What about if you're dealing with stock trading, some kind of niche market like Forex trading or something like this, right? You need to make sure that your data are standardized to whatever you're working with so you could try to do your predictive modeling. Here's an example of what UTC looks like by itself, that +00 that I was talking about before. And here's our observation. And when you do this date time formatting from pandas, it's really simple here. And if you want to add in the UTC, you could just chuck it in as UTC equals true, just to get you a basic standardization for your data so people will know where you're working with for whatever time zone. It's basically zeroing it out. If you were actually trying to convert this, you could do the .tz_localized, convert it to your UTC, and then whatever kind of, I just made up a US time zone, you could do Mountain, Eastern, whatever, depending on where you're at. You could be in Kuala Lumpur, whatever it is, you find your local one if it's available and throw it in there so you can start standardizing your data. Distinguishing the difference between the time zone localized and the convert, the time zone localized is taking your naive data or something that's unaware, agnostic of any time zone, and making it aware using the UTC. Whereas the TZ convert is taking your aware time object and creating a time zone for it for whatever you specify. When I try to run this again, the data are already converted, thereby giving me this error, not allowing me to run this. And if you scroll down, it'll say this is already a TZ aware object. You can't use the convert. It's already done for you. So if you ever reach that error in the future, that's why. But that'll be the conclusion of this video. I hope it wasn't too abstract and you could kind of follow along, because it's an abstract concept that has real implications for your data and analysis. Feel free to hit me up on my socials. I hope I was able to explain this. It's kind of a difficult topic to try to explain, but please like, share, and subscribe. And if you subscribe, turn on that notification bell. I'll see you in the next video. Thank you for anyone who's helped support the channel over the last few years, and those who've left constructive feedback and comments that were positive, because I greatly appreciate those. Have a good one. See you in the next one. Bye.